In this video, we are going to go through the complete process of designing a part, right from establishing the design requirements to preparing the manufacturing drawings. Here you will see the overview of a typical engineering design process. We first identify the requirements of the design as per the application. Thereafter, idea sketches and corresponding free body diagrams are drawn. The external forces in the free body diagram give rise to internal forces and moments, and the resulting stress strains are analyzed. Steps 2 and 3 are iterative, and it takes some time to come up with a design which is successful in all aspects. Once the design concept is finalized on paper, the CAD detailing is done on SolidWorks, which is then followed by manufacturing drawing preparation. So here we are going to review the general design process for any part. The first step will be to jot down the design requirements. For example, does the part need to be lightweight? Does it require precise location? Or does it need to resist deformation in a particular direction? Answers to such questions will give us a clearer picture on what we really need. Once this is done, you need to identify and quantify the forces and moments that are acting on the system. Draw the free body diagram, shear force and bending moment diagrams for that part. Now, based on these constraints, you can start conceptualizing the design. Think over the design ideas and iterate until you are sure that this will be a successful design in all aspects. Once this is done, the next step is to go for CAD modeling. Here you will be able to use your skills in SolidWorks for designing the part. Always make sure that the part assembles correctly with the rest of the system. One way to do this efficiently is to use inbuilt tools in SolidWorks like clearance verification, interference detection, and hole alignment. You can find more about these features over the internet. Once the CAD file is ready, we can go for manufacturing drawing preparation. Although preparing manufacturing drawings is easy, selecting the appropriate tolerances involves some thought. It is important to realize that manufacturing cost of any part varies exponentially with the tighter tolerances. So over-precise tolerances should be avoided. In the next slide, we are going to learn how to select the appropriate tolerances for any part. The first step towards deciding the tolerances is to determine the quality of fit that is required as per the application of the part. Page numbers 3.4 to 3.6 of the PSD data book give you a broad overview of different types of fits and their applications. Which hole and shaft combination to narrow down is based on the specific application of that part. You can also search the preferred combinations for different applications over the internet. In the next slide, we are going to take up an example on how to proceed from selecting the hole and shaft combination to determining the actual tolerances of the part. Let us consider a case where we want to find the tolerances for a close location fit, specifically H7, H7 between component A and component B. The numerical tolerances for these components can be found from this table given in the PSD data book from page 3.7 to 3.10. Component B, which functions as an effective hole, has a basic dimension of 15 mm. Therefore, its tolerance for capital H configuration according to this table is plus 18 microns. Similarly, for component A, which functions as an effective shaft, the tolerance would be minus 15 microns. So this way you can find tolerances for any pair of components. Now you can incorporate these tolerances in individual manufacturing drawings of A and B.